Hi everyone watching Techno Day. I'm Ada Rose Cannon, a developer advocate for the web browser Samsung Internet, and I'm also co-chair of the W3C Immersive Web Groups. I'm here to talk about building augmented reality. Before I start talking about that, I would like to tell you a little bit about Samsung Internet. Samsung Internet is an Android web browser which is maintained by Samsung. It's a fork of Chromium, with a focus on features for users who are more privacy aware and power users who like having more control. It has built-in ad blocking and tracking prevention, and a fully customizable interface to let you take control of your web browsing experience. You can download it from the Play Store on any Android phone, and I really recommend trying it out, especially if you are a web developer. Samsung Internet has a lot more users than you would expect, so many of your users might already be using it. And since we are a Chromium fork, there may be some small differences with mainline Chrome, which can cause issue in your web pages. As a developer advocate, I try to help developers with the latest features in the web platform, to build websites which make the most of everything the web browser can offer. If you have any questions about Samsung Internet or Webxr, please reach out to me or any of the other members of the Samsung Internet team through email or social media. Now let's get back on topic. Building your first augmented reality experience. There are many tools for building augmented reality experience. There is a way to build augmented reality which with a single build will let you target a wide range of devices. It will let people try it out without needing to download any additional apps or software, and it can be shared by just using a single URL. It uses existing web technologies, some of which have been in active development for over 10 years with humongous communities. I'm talking about Webxr. Webxr, at its core, is an API designed to access the sensors and displays of immersive hardware, such as virtual reality headsets and augmented reality devices. By knowing what the user is looking at, we can render a scene using WebGL from the user's point of view, and then send it to be displayed on the headset. And if you do this at the frame rate of the headset, you will give users the feeling of being inside a virtual scene. The API is designed to be abstract enough so that it will support the wide variety of different formats immersive technologies may take in the future, ensuring that experiences made using Webxr continue to work on new devices, even devices which were inconceivable when the enabled experience was made. Here is a little demo of Webxr in the real world. It's launched from a normal web page. It uses the device sensors to work out its position in 3D space. It can detect the walls and floor. The scene is rendered using WebGL, and it is then displayed on the device. The second half of this talk will be going through building an experience like this. But before we get stuck into actual code, I'm going to mention a few of the other sorts of devices Webxr can support. So the demo you just saw was running on a smartphone. This is probably the most common sort of XR-capable device you will find today. Many modern smartphones have these capabilities built in. These capabilities used to be uncommon, as older AR-capable phones needed specialist hardware, such as Project Tango. But modern methods of handheld augmented reality often rely on machine learning to interpret the camera feed from the phone, to perform the real-world sensing required to do good augmented reality. The next most common XR device we'll encounter today are VR headsets. These are surprisingly popular amongst consumers. Compared to a few years ago, the headsets of today have many more features, such as full 6 degrees of freedom tracking and 2 tracked controllers, and even advanced features like hand tracking. They have really come a long way. The final device I want to mention is probably the least common you'll find today, which is augmented reality headsets. These are also known as mixed reality headsets. These devices are currently expensive and hard to get access to. They are more common in industrial applications rather than as consumer devices. But these devices are becoming cheaper and smaller at a dramatic rate. I can really see these devices becoming popular consumer products over the coming decade, as they integrate more and more seamlessly into our day-to-day lives, especially when you compare them to virtual reality headsets, which isolate you from your life. But here are some of the things you need to be aware of when working with these kinds of devices. So the most fundamental XR device is the virtual reality headset. It's supported by the very core module of Webxr. The displays, as expected, the displays are in front of the user's face and move with the head. It can do stereoscopic rendering and probably has some kind of separate controller for interacting with the virtual world. Whereas handheld augmented reality is a very different experience from virtual reality. The display is held in the user's hand rather than on the user's face. The display is also simultaneously the controller for interacting with the scene. It won't have any kind of external controller, most likely, and it probably won't be stereoscopic because it's a 2D display on the phone. But it might have some advanced capabilities like real-world tracking. The Webxr API provides some great abstractions, making it possible to write code generic enough to handle both of these different situations without needing to be aware of what sort of device the user is using. Many developers tend to want to only focus on supporting a single targeted device at a time, i.e., just handheld augmented reality or just virtual reality. But I personally think this might be a mistake. It is a very similar pattern to when mobile phones first emerged. And when they started to access the web, developers made separate M.dot sites to target mobile phones. Whilst easier to develop for, this caused fractures in the web ecosystem, which you can still see today on many websites. One major reason this is a mistake is that if you can support AR handsets and virtual reality headsets at the same time, you are probably in a good position to support AR or mixed reality headsets. These headsets share many of the same properties of both augmented reality handsets and virtual reality headsets, and will in time become the dominant platform. So if they are not supported, eventually your experience will become harder to use, as people tend to be using the more advanced AR headsets. Anyway, that is enough of me preaching to you about how I think the web should look. Let's actually try and build something. Webxr relies on a graphics library like WebGL, WebGL2, or WebGPU to work. These languages, whilst very powerful, are very unfriendly. You generally need a 3D engine to work with them. Here are a selection of the 3D engines which can support Webxr. I've included Unity, even though it doesn't support Webxr out the box, because there is a really good plugin you can use to export a Webxr-enabled WebGL experience. I don't think it's the best for the web, because the files take a long time to download and the user is left staring at a loading bar. But it does let you do a really good experience, and if you already have experience with Unity and want to try building stuff with Webxr, it's a great place to start. For our demo today, we're going to be focusing on AFrame. AFrame is a really nice language for those of you who don't have a huge amount of graphics experience. I myself still use it for most of my projects, just because I really like the way it's made. It's declarative and controlled with HTML. It gives you a surprising amount of power. One really amazing aspect is its huge and active community. The community plugins are fantastic and give you really powerful effects without you needing to have a deep understanding of how they work. Unless you want to, that is. The documentation is also really good. It includes some great articles and examples, as well as detailed descriptions of what all the different components do. To show you the power, here is the AFrame boilerplate code. At the top of the example is the script tag for the AFrame library, which adds a bunch of new HTML elements for doing 3D work. But before I really get into that, I'm going to introduce some AFrame lingo. So the HTML tags AFrame use are known as entities, where each entity represents a 3D object. The attributes on these entities are known as components. They describe the different behaviors that an entity can have. The default entity, which has no components, kind of like the empty div for 3D stuff, is the a-entity HTML tag. And you can use any component on this to make custom entities, such as geometry and material, to give it shape and color. But aside from the a-entity, the default one, there are other entities you can have, such as a-box, which renders a box. It uses the geometry component by default to give you a cube, which you can then customize to make into other kinds of boxes. It has new HTML elements for all kinds of things as well as boxes, spheres and cylinders like in the example, but also things not included in the example like lights, cameras, animations, 3D models. The end result is a virtual reality and augmented reality ready 3D web page that runs in your browser. We're going to use this boilerplate code to start building our example augmented reality app. I'm now loading the AFrame documentation. I've set up a HTTP server a bit earlier. When we view this on the phone and press the AR button, you can briefly see through the phone's camera before everything gets covered up. It all gets covered up because the a-sky element covers the whole scene. Fortunately, we have a small library to help with this. I'm working on a pull request at the moment to make this behavior a default part of the AFrame library, but right now you can use this third-party library to help with augmented reality. This library defines some components, one of which is a simple component that makes the element invisible when the user enters augmented reality. That is the one we will use for the sky. We can now clearly see my office behind the 3D models, but still the augmented reality effect doesn't look quite right. Let's take a closer look at the code. Oh dear, these objects are positioned 5 meters away, and some of the objects are over 2.5 meters tall. And this is a good time to mention that the units and coordinate system for Webxr. In Webxr, all units are in meters, so this 1.25 means 1.25 meters. And the coordinate system is such that x goes to the right, y goes up, and z goes out of the screen towards you. So if you give something negative z, it's probably going to be placed further into the scene, at least from the default starting position. So these objects, which are meters in size and meters away, are too big to realistically fit inside my house. They may work really well in virtual reality, where you have boundless infinite spaces and large objects look impressive, but augmented reality has real-world constraints, so we should shrink these objects. We will do this by moving them inside another A-entity, with no other components than scale. The scale component sets the size of an object, and all of its children, and all of their children. We will also move them forward by 5 meters so that they are in the very center of the entity, so that as we move and rotate the entity, they move about the center point of that object instead. When you refresh the page, the objects aren't immediately visible because they're below the eye line. So we're going to move the camera lower so that they are still visible in the normal view. We will do this by adding our own A-camera, and by providing our own A-camera, it overrides the default one that AFrame gives you. These objects look okay now, but they still don't match up with the real world. And that is because the scene is currently unable to scan our environment. So the next thing we need to do is request the hit test feature from Webxr. To configure Webxr in AFrame, you use the Webxr component on the scene element. We will request the hit test optional feature. To use this feature, we will use the other component provided by the library, which is AR hit test. This component is designed to cast hit test rays out of any input device it finds, and if it can't find any, it will just use the viewer position, so it fires one out of wherever you're looking, throughout the middle of the screen. This progressive enhancement behavior means that it should work reliably on whatever devices come along, whether it's a handheld AR phone, a virtual reality device, or an augmented reality headset. We add this component to our collection of shapes, and then they get positioned and orientated with the floor. If I point it at the wall, then they get correctly positioned there too. This is okay behavior, but we probably want to put it somewhere and leave it there. Fortunately, the component can handle that too. The target property will cause it to update the position of another entity to wherever it's currently targeting whenever you tap the screen or pull the trigger or any other kind of input event. So let's make a simple rectangular reticle and use that to position the element. We will give it the hit test component and make its target be the other shapes. So we'll give the other shapes an ID, and then we will set the target property of the reticle to be that query selector. This now has the basic behavior that we want, but is quite boring. It's just some primitive shapes. Let's find a more interesting model. I get a lot of my models these days from Sketchfab. They have some really nice models at cheap prices, and even some Creative Commons models you can use as long as you give attribution back to the original creator. This cactus model is great, so we will download it and try it out. You will often see models come in too large when importing them into WebGL scenes. Many 3D models like to use millimeters or centimeters for their units. But as I said earlier, Webxr uses meters, so something that was made to be 200 millimeters tall ends up being 200 meters tall, 1,000 times larger. You can use the scale attribute to make it smaller, or you can load it into a 3D modeling program like Blender and tweak it there. Blender is a really scary program if you have never used it before, but it can be really powerful once you are used to it. If you start to do a lot of 3D graphics, it can be a really useful tool just to get the handle on it. Even if you don't expect to do regular 3D modeling, just knowing it can be very handy. Here I'm using the AGLTF model entity from AFrame, which automatically loads 3D models, but it doesn't handle their animations by default out the box. Now we've got the cactus to the right size, let's get it dancing like it was on Sketchfab. I mentioned earlier the rich library of components in the AFrame ecosystem, and one of these projects is called AFrame Extras. This is a project that provides many useful tools for AFrame. The one we're after is called Animation Mixer, and by adding it to our animated 3D model, it will automatically find these animations and start playing them. Make sure you remember to put the script tags after the AFrame script tag. That way they get loaded to the AFrame library. It's rotated by 90 degrees away from the camera, so I'm going to rotate it 90 degrees around the y-axis so it points back at us. And it looks great on the phone. Finally, the last thing I wanted to touch on is DOM overlay. This is a pretty new feature to Webxr. It isn't present yet in Samsung Internet, but it will hopefully be arriving very soon, but you can use it today in Chrome. DOM overlay is used to make 2D interfaces out of HTML and CSS for augmented reality applications. Right now it's only available on handheld augmented reality, but it's still extremely useful. It's simple to use. You just tell Webxr which element to turn into an overlay, and it will be placed full screen over the entire scene. You can use this to add buttons and text and just any normal HTML elements which you can control with JavaScript and CSS. We will use the DOM overlay to add a title and a credit for the 3D model. So here I'm setting the overlay element on the AScene element to use this particular div. And I'm just going to put some content into here, just like a title and a description. For the description, I'm going to copy and paste the description, and then I think we're finished. I'll copy the description from Sketchfab. It's also extra important to include the license details in the source code itself and the attribution. Also, I'm going to add some CSS to make it go full screen, or at least on top of everything on the web page as well. I'm trying this out in Chrome rather than Samsung Internet because it's not supported in Samsung Internet yet. And as you can see, the text is still at the top of the screen, even in augmented reality, whereas normally it would disappear. Cool, right, that was the end of the video. I think it's time for the FAQ part. Now we've finished building the demo, I'd just like to go through some frequently asked questions, which I get a lot. And if you're really interested in building something with Webxr, I really hope these help you out. So probably the most important question is, what kind of experience is Webxr best for building? And to be honest, the simpler the better, really. Like when you start needing to download big 3D models, it can get quite slow and probably isn't best for the web. Users get distracted really quickly. Anything where you want users to get involved as quickly as possible is perfect for Webxr, because you don't have to download anything or go through an app store, and the users don't have to pay money to the app store to use them, and the app store won't take any of your revenue. Like, this is really great for getting people involved really quickly. So if you want to do something where you want like a crowd of people involved, Webxr is probably the best thing to do because they don't need to install anything in advance. If you need it to be shareable on social media or just quickly shareable with a URL, then it's easiest to do it with Webxr because people can share that in all the different ways they're used to sharing URLs already, through social media, through shortcuts, through all kinds of things. And if you want to build something to reach as many devices as possible, but you don't care too much about what devices people are using, again, that's another great use case for Webxr. It's designed to reach as many people as possible. But what kind of stuff is it bad at? Well, if you want to have some kind of super large environment, say like a video game where a person is going to spend many hours in a single environment, traveling from room to room, where you're going to need lots of detailed 3D models with big textures. This kind of thing is unfortunately not ideal for Webxr because the models are just too large. If the user has to stare at a loading bar for too long, then they're probably going to get bored and leave the web page. And if you're really smart and very careful, you can download assets like on the fly as the user are using the scene. Unfortunately, you have to make sure you have to parse them off the main thread so that you don't slow down the rendering and make the user potentially ill. So doing dynamic loading in the web is possible, but it can be very tricky to pull off. And one thing which is a shame to say right now is that the web isn't super great at the really good graphical fidelity, like the AAA game style of stuff. You can do some tricks to make stuff look really good, but if we're looking at WebGL and to an extent WebGL 2, you're not going to be able to do that much. The upcoming API WebGPU looks to solve many of these problems by providing an even lower level API, but that's not available in browsers quite yet. But it's hopefully not going to be too long until this won't be much of an issue anymore. Fingers crossed. And I already mentioned about large textures and large downloaded sizes. The other thing which is probably important to mention is that if you want to ship something to a single device targeting a small group of users, then you might as well ship something to an app store. Because they're all going to be on the same device, you can test it to make sure it works really well on that device, and the users can just preload it, and you can make it as big and as graphically intensive as you need. And it's probably going to be a slightly easier thing to do. But if you want to, on the other hand, if you want to reach many people, then go for Webxr. So I know there's people here who aren't web developers, but if you're a graphics developer and Webxr sounds really interesting to you, well, how do you get started? Well, if you've used Unity, I mentioned earlier the Unity exporter, and I'm going to mention it again because it is really pretty good. And yeah, the downloads can be pretty large, but they're not so bad. And if the user is ready for a really interesting experience or willing to sell something really good, then they might be willing to wait just that little bit longer. If you wanted something a little bit more webby, but still more programmatic that lets you get really into the dirt of graphics coding, then take a look at Three.js and Babylon.js. These are both JavaScript 3D engines that give you really deep low-level access. AFrame is actually built on Three.js, so if you want to do the really deep nitty-gritty stuff, you can still do that in 3.js without any, you can still do that in AFrame without any problem, because you can still access the lower level bits. But if you're more of a programmatic developer rather than a declarative developer, Three.js might be, or Babylon.js is where you might want to go. All right, conversely, Webxr sounds really good, but you're a web developer and not sure how to get started. So I showed you AFrame here. And the reason why is that as a web developer, because it's HTML, you can code it using JavaScript and well, not CSS, but you can code it using JavaScript exactly as you'd expect and do all your standard web development practices because it's just HTML, which is really nice. But if you're more of a React kind of developer and like you got more of that stack, then check out React 3 Fiber. I'm not sure if it can do Webxr out the box, but it's supposed to be really good, and it'll be a really good way to apply your React skills to doing 3D graphic stuff. And I think that looks really neat. Oh yeah, just showing the AFrame stuff. All right, so what's the support like for Webxr? And this is a really complicated question because it depends on the operating system. Like, for example, some operating systems can't handle like VR or AR that well yet. It depends on the browser because the browser itself has to support the Webxr device API. And it depends on the hardware you're using. Like some pieces of hardware might be too different or they don't have support in the operating system yet. But like, despite all this, generally the answer to this question is pretty good. A lot of the really popular consumer devices have Webxr support. And Apple even just announced that Webxr is now in development for them. So I can't wait to see what Apple produce for Webxr and what devices it's going to support. If you want more detail, check out the support table on immersiveweb.dev. Immersiveweb.dev is a web page which I try to maintain to keep up to date with all the latest Webxr information. So it's a good place to go, even if you just want to get started and find some different guides or some documentation. This is a tricky question. Can you access the camera feed in augmented reality? And unfortunately, the answer is no. So people don't like it when a web page turns on the camera and has it on for a large period of time in their house, because all this information can just be uploaded to a website. the Webxr Device API has to maintain the high standards the web has for privacy. And so we can't just give raw camera access, especially if you combine it with the depth sensing, you can start doing some real nasty stuff. But what we might try to do is give you some limited access in the future. Perhaps we'll do something like give you access to specific uses like detect a face, detect an image marker, detect a QR code marker. But we probably won't give you just raw camera access at the same time as Webxr. This is also partly for technical reasons, just because Webxr uses the camera, and then you can't have two things using the camera at the same time. But mostly the privacy reasons. Can you use HTML in Webxr? So kind of. So you can use the DOM overlay API, which only right now works in handheld augmented reality, like on phones and stuff like that. We're working on getting more HTML access through another API, which will be for a more general use case, and it'll work in virtual reality and augmented reality as well, hopefully. You can do hacks, like where you render a web page into a canvas and then apply that canvas as a texture. But it's a bit of a dirty hack, and it's not ideal, especially when you want to start doing interactions with that canvas. Like it's possible, but it's very difficult and a bit flaky. And I wanted to highlight, once again, using Webxr with Unity. So as I said before, the output is big, but it works. But it does mean you can do some really, really cool stuff. For example, someone ported the really popular tilt brush application to the web through a Unity exporter, which I think is incredible. That's some amazing work right there. And it's really fantastic seeing some of the really high production value, like native applications, start to come over to the web and Webxr. And I look forward to the really high production value stuff that's starting to come out now. And this is more of a technical question. Is there any connection to the OpenXR standard? And aside from some of the people working in both standards, generally there isn't really a connection between them. Although what is quite interesting is that there are some Webxr implementations that are built on top of OpenXR. And so if you're on a platform that supports OpenXR, then probably Webxr will work there as well on the same pieces of hardware, which is really, really nice. Anyway, that was the last of my questions. If you have any more questions which I haven't answered throughout this talk, or just want more information about Webxr in general, I love talking about it. I can talk about it for hours. So please just come ask me questions on Twitter, or email our team, or contact our team on Twitter. We're really happy to answer questions about general web development as well. Anyway, thank you so much for listening to my talk and listening to my questions and stuff. And I really hope you enjoy the rest of Techno Day. Thank you so much. Bye.